Okay, so let's just quickly remind ourselves, because we only looked at it briefly on Friday, how we go about multiplying two matrices together, okay? So what I'm going to do is I'm going to write out these two matrices again. So saying do A first, then B. So A multiplied by B. The order matters, right? So A first goes 7, 4, 2, 6, 8, and -5. And then followed by B. So I'm going to have 7, 0, -1, 8, 2, and 5. Okay, so how do we go about multiplying these two matrices together?
3 by 2.
Good, so you're looking at dimensions of the matrices first. So this matrix is a 3 by 2, I agree with that. What are the dimensions of this matrix?
Opposite, 2 by 3.
Yeah, good, because there's 2 rows and there's 3 columns. So it's a 2 by 3. Fantastic. And of course, I'm multiplying these together. Now, first question, can I multiply these matrices together? Do the dimensions agree? Yeah, they do, don't they? Because it's the inner two dimensions which we have to check. We have to check this one and this one. If you think back to Friday, I think I gave you an example with sandwiches and the amount of sandwiches sold per day. Okay, so I think this corresponds to the days, this corresponds to the sandwiches, this corresponded to the sandwiches in the second matrix, and this corresponded to, say, like the cost. Okay, so I needed to make sure that the number of sandwiches matched in both tables. Otherwise, we're in trouble and we don't know how to combine them together. Okay, so you have to make sure the inner two matrices or inner two dimensions match. In this case, they do, which means that we can do this matrix multiplication. Does that make sense? Yeah, do you remember that? Okay. Now, what are the dimensions of the resulting matrix? Yeah, good. It's the outer two dimensions which tell you the dimensions of the resulting matrix. So it's going to be a 3 by 3 result. Okay, so in other words, I'm expecting a matrix down here which has 3 rows and 3 columns. Okay, so there's an element here, 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 and here. There's 3 rows and 3 columns. Does that make sense? Okay. So let's just remind ourselves. Let's go for this element here. Now, what position is that element in? Fantastic. It's in the first row and first column. Do you see that? So it means I'm going to be using the first row from this matrix and the first column from this matrix, and then I multiply corresponding elements together and add them. Okay, so let's do this. What's 7 times 7? Add 4 times 8. Not quite. 7 times 7 is 49.
49.
Add 4 times 8, which is 32. So it's going to be 81, isn't it? It's going to be 81. You happy with that? Okay. Let's go for this element here now. Let's go for this element here. So what position is that element in? What position is that element in? So first row and second column, which means I'm going to be looking at the first row of this matrix and the second column of this matrix. Remember, it's always rows first, then columns. Okay? And I just multiply corresponding elements together and end up adding them. So what's 7 times 0 plus 4 times 2? Good. So that's 8 there. Okay? Now have a look. I'm going to go for this element here now. What position is that element in? Fantastic. First row, third column, which means I'm going to be using the first row from this matrix and the third column from this matrix here, and then multiply corresponding elements together and add them. You get the idea? So what's 7 times -1? Add 4 times 5. Was it? 13, right? Because 7 times -1 is -7. Add 20. 4 times 5, yeah? So that makes 13. Fantastic, that's the first row done. Now let's try and find some other elements. Okay, let's go for this element here. So what position is that element in? Fantastic, second row, first column, which means I'm going to be using the second row from this matrix and the first column from this matrix. Okay? Then you multiply corresponding elements together. So 2 times 7 plus 6 times 8. 62. Do we agree with that? Yeah? Okay. Now just because I'm getting a bit tired of drawing them all in, let's see if we can do it without drawing the red rings. So if we go for this one here, what position is that element in? Fantastic. Second row, second column. So we're going to be using this second row, so almost imagine reringing that one, and this second column here. This second column here. So let's check it. It's going to be 2 multiplied by 0 plus 6 multiplied by 2. What's that? 12. Fantastic. What about this element here? What position is that element in? Fantastic. Second row, third column. Which means we're going to be using the second row and the third column. Let's do this. 2 times negative 1 plus 6 times 5. 28, yeah? Good. Okay. This element here, what position is it in? Third row, first column. So we're going to be using the third row and the first column. Okay. So 8 times 7, add negative 5 times 8. What's that? 16. Do you agree with that? Yeah? Okay. What about this element here? Nearly finished. Third row, second column. So third row, second column. 8 times 0 plus negative 5 times 2 is negative 10. Fantastic. And this element here, third row, third column. What do we get? 8 times negative 1 plus negative 5 times 5. Negative 33. Do we agree? Is that okay?